I'm going to tell you a story about what happens when our best available therapy is actually not bad, but it's not perfect, and how we can get it the last mile, basically. And this story begins for me in 2001 when I was working in my lab at UCLA, and I got a call from a friend of mine from graduate school, and she said, "Steve, what are you up to?" And I said, "Well, I'm trying to cure cancer." And she says, "Oh, really? So am I. What do you got?" And I said, "Well, I've got DNA microarrays, high-throughput molecular screening, I've got gene therapy vectors, all kinds of amazing biotechnology." She says, "Sounds great, but I've got a video game." I thought, well, what I don't have is my slide advancer. Well, that sounds like more fun than the biotechnology, but is a video game going to cure cancer? How's that going to happen? And after she explained to me how that was going to happen, I went to work for her, because her pitch seemed like the most promising opportunity I'd heard in a couple of years in biomedical research. So the story goes like this. Basically, well, no. By itself, a video game isn't going to cure cancer, but by itself, nothing else cures cancer either. To cure a case of cancer, a whole system of things has to go right. The patient has to recognize that there's something wrong and get themselves to a doctor. The doctor has to accurately diagnose that disease and prescribe the appropriate treatment. Pharma has to develop those treatments and get them out into the world. And the patient then has to do their part again by making sure that they take those treatments in the way that's going to allow them to work as effectively as possible. And in the last couple of decades, as we've seen here, there's been some really remarkable advances in some elements of this system. We now, as you've heard, have these amazing molecular imaging technologies that allow us to literally peer inside the human body and diagnose cancer with a precision that was unimaginable a few decades ago. We also have a completely new recipe for how we make cancer drugs. We can understand, as you've heard, the molecular damage that causes cancer in the first place, and we can begin to rationally engineer new drug molecules that interact with that damaged molecular biology and set it straight. But when it comes to helping the patient be the most perfect executor possible of their own treatment, frankly, our technology today is every bit the same as it was more than a century ago. We talk to patients. We give them pamphlets, we show them billboards, we cajole them, implore them. So here's an example. If you're a teenager and you have the most common kind of cancer in that age group, acute lymphocytic leukemia, when you're through your primary treatment, you've been through the hell of chemotherapy, your cancer is in remission, your symptoms are gone, you're feeling actually pretty good. It's a great day. You're being discharged from the hospital. Your doctor will probably give you this lecture on the way out the door, explaining why, although you feel like you're fine, it's really important for you to take follow-up maintenance chemotherapy for the next 3 years. And there's a fairly extensive explanation about why you need to do that, but you probably can't read it. You don't actually need to pay any attention to it, frankly, because our patients don't pay that much attention to it either. And it's not like they don't pay attention to it, but presenting the argument in that form doesn't grab them in the way it needs to make sure that they actually carry out that maintenance chemotherapy regimen perfectly. And what we know is if they miss as few as 20% of those doses, their risk of having a rebound of leukemia doesn't go up by 20%, it goes up by more than 200%. They literally double their avoidable risk of death simply because they're not perfect executors of their own treatment. So that's an area of significant challenge. What can we do here? How can we harness the power of modern technology to change the patient side of the equation? Well, how about this? How about we shrink the patient down to the size of a cell, put them inside the bone marrow of a person who's in remission from acute lymphocytic leukemia, and have them pilot Roxy, the microscopic nanobot, around inside the bone marrow of this patient who thinks that everything is fine. But you and Roxy discover that, in fact, there's still a few enemy cancer cells there trying to regrow the colony, whereupon you begin to lay waste to them with your radiation gun and your chemo rockets. So that's the remission video game for cancer. And that represents a whole new way of trying to harness the power of the patient in the service of their own health, essentially by having fun. So it looks like fun, but how does this have any hope of working at all? Well, the key to understanding why this kind of therapy might work, in just the same way the key to understanding why something like Gleevec would work, is understanding what went wrong in the first place. So to explain that, we have our friend Ranjit here. Ranjit's a 17-year-old guy getting ready to go to college. Ranjit's behavior today is governed by the future. It's governed by the things that he wants to do in life, the places he wants to go, the things he wants to become. It's all about the future for Ranjit. So Ranjit wants to, for example, travel the world, go to interesting, exciting places, meet interesting people, and synthesize those experiences into vivid, compelling stories that really move people, and win him the Oscar for Best Screenplay. And in fact, he's not totally done there. Actually, he'd like these things to win the Nobel Prize for Literature as well. And when he's not busy winning the Nobel Prize for Literature, Ranjit would like to be a rock star. So these are the things that Ranjit cares about. This is what's in his head right now. When he's out of the hospital and in the real world, he's gone back to being Ranjit. He's made it through the gauntlet of his initial therapy, and he's on the road to being Ranjit now, the real Ranjit, not the sick one that has cancer. But if Ranjit has acute lymphocytic leukemia, in addition to charging towards this future, we need him to be present here and now every single day, taking his 6-mercaptopurine maintenance chemotherapy pill. Every day for more than 3 years. Basically, that's more than 1,000 pills that Ranjit needs to take at the right time, in the right dose, in combination with the right set of other medications, which incidentally changes from day to day. And what we know, as I mentioned earlier, is that about 20% of kids who are on maintenance chemotherapy miss more than 20% of their doses. So that's Ranjit's effective therapy. If he is so busy thinking about the healthy, vibrant person that he really is at heart, that he forgets to be the sick patient who needs to take his maintenance chemotherapy. Okay, so that's our challenge. How are we going to help Ranjit be perfect? How are we going to get him to remember every last one of those doses? Well, one person with an idea about how you could do that was Pam Omidyar. So this is Pam staring down the tube of a microscope, working as a biological scientist at Stanford University. And every day, she watches cells of the immune system battle it out with cancer cells. And she realizes that because she can see this happening before her very eyes, so that she has a much more kind of vivid and compelling experience of this situation. And she thinks that if cancer patients could just see what she sees, that they too would think in a completely different way, not only about their disease, but about the significance of what seem like otherwise mundane behaviors, like taking every last one of those pills. And then Pam goes home at night and plays video games. Pam loves video games because they put her in the thick of the action. They put her in control of her destiny in some sense. And although she doesn't win all the time, Pam notices that the more she plays video games, the more often she wins. In some sense, she becomes a more powerful and effective human being, and she likes that sense of growth, that sense of power, the sense of being in control of your destiny. So at some point, Pam puts 2 and 2 together and comes up with 25. She realizes that if she could just build a video game for kids with cancer that shows them this epic drama, this struggle taking place between health and death in their bodies, and helps them sort of understand or reconstrue things like taking your maintenance chemotherapy as not part of the burden of having cancer, but this essentially heroic contribution they can make on a daily basis to tipping the playing field in favor of life and health, that might really make a big difference in behavior in the way that lecture really couldn't. So seems like a great idea, but it's going nowhere because Pam knows that to make a good video game, you need a lot of people, you need a lot of money, you need a lot of time. She doesn't have any of those things. But the picture looks up when her husband comes home and says, "Honey, I invented eBay. What do you want to do with the rest of your life?" And Pam's first act was to go out and found Hope Lab, a foundation dedicated to basically harnessing the power of fun in the service of health by changing people's behavior. And she hooks up with a bright, talented health psychologist named Pam Cato, and the two Pams basically set about brewing up a recipe for creating play experiences that change people's psychology. And here's a couple of ingredients in that recipe. One of them has to do with the backstory. So the backstory here is you're in the body of a patient who thinks they're fine, yet you can see that they're not fine. There's still a cellular threat about you're not completely out of the woods just because you feel like you're fine and you're out of the hospital. But that's delivered in a way that's not lecturious, if that's even a word. Talking to teenagers, the last thing you want to do to get them to do this thing is actually tell them you think they ought to do this. That's a losing proposition. But if you can show them what's happening instead of ramming it down their throats in a way that they can basically experience this and in some sense live out the contingencies that we don't want them to live out in the real world, if they can live that out in the virtual world instead, it's a whole lot better. So that's one part of the story, is communicating in a different way. But another part of the story is there in that big chemotherapy blast cloud you see. So chemotherapy is undoubtedly the most ambivalent concept imaginable in most cancer patients' minds. They know in their heads that the chemotherapy is primarily responsible for killing their cancer, but they feel in their gut that it's killing them. And they're right, it's killing them just a hair more slowly than it's killing their cancer. It makes them sick, miserable, wretched, awful. So it's not a surprise that somebody who's had that experience of chemotherapy and now they're through it, they're out of the hospital, doesn't think that this pill called chemotherapy is the one thing I really most want to do in the next 5 minutes is take that maintenance chemotherapy pill. Who's going to think that? Well, actually somebody who might think that is somebody who now thinks of chemotherapy as the bullets in your gun, the rockets in your launcher, the tool that you're going to use to achieve what you really want. The way you are going to become the healthy, vibrant Ranjit that you know you really are. Because, as he pointed out, you're not a cancer patient ultimately. Okay, sounds like a good idea. Does it work? So the nice thing about the PAMs is not only are they creative geniuses, but they're also good scientists. So they go about testing this approach using the same infrastructure that you'd use to test a new cancer drug. They carry out a randomized intervention trial in which they recruit 374 adolescents and young adults currently being treated for cancer. And they randomly select each one of them to receive either a control commercial video game or the remission video game for cancer. And then they follow those kids around for months afterwards, checking up on things like, how many of these kids are at really material risk for a rebound of leukemia because they have critically low levels of chemotherapy in their blood? And what they see in the control group is what we see in every other study of kids this age. About 20% of these kids are really at material risk for a rebound of cancer because they've got these dangerously low chemotherapy levels. But in the remission group, that number is cut by more than half. So maybe a video game really can cure cancer. Obviously not by itself, but certainly by harnessing the power of the patient to control, in some sense, the therapy that goes into their body. If that's a material contribution to the risk of cancer mortality, which it really is for kids with ALL, this looks like it can knock down more than half of that totally avoidable risk of death. So that's not bad. But it's also promising in a much broader way. So for example, if we can do this for things like maintenance chemotherapy and taking every last pill, what else could we possibly do with the power of play? So that's what I'm really interested in at Hope Lab is, what's different about this kind of play-based approach to behavior change? How does that seem to work so much better than just lecturing kids? All of these kids got the lecture, but there's a big difference in the number that are actually in the safe zone in terms of their health. So a lot of what we've been trying to do is understand, really, what's going on in the mind of somebody who's having one of these play-based experiences. So we literally peer inside their brains. We bring kids into the lab, we roll them up into a functional magnetic resonance imaging machine, and we look to see what happens when you play remission. So for example, one structure that gets super excited when you play this video game is a trio of structures in the limbic system called the caudate, the putamen, and the nucleus accumbens. These are structures that are involved in positive or incentive motivation, in getting what you want, in seeking after the thing you care about most. And it's not so much a structure that lights up when you get what you want as when you think you can get it, when you're on the hunt for it, when you can, in some sense, smell victory just a short distance away. So this is a, if you will, sort of the infrastructure of excitement in your brain, of positive motivation. Another structure that activates strongly is the thalamus, which is basically the internet of the brain. It moves information from one part of the brain around to other parts of the brain. If you wanted to harness the totality of a person's mental faculties in the service of one particular goal that you're engaged in right now, this is the structure that you'd like to see activated. And a third structure that activates is a small structure with outsized importance. It's the hippocampus. And the hippocampus is basically the gateway between your momentary experience of the world and long-term memory. If you want a short, transient, play-based experience to exert an enduring impact on your attitudes and behaviors over days and weeks and months afterwards, this is what you'd like to see activated in the brain. And we know that the activation of these key brain regions depends critically on your role as a participant in the drama that's taking place here. As we know, actors learn their lines much better than the audience can remember them. We know that being an actor, being a participant, the interactivity of this play experience is essential for these patterns of brain activation, because if we simply hold constant the information that you get from this experience, if we capture the video stream and the audio stream from one person playing remission, and we simply passively play it back for another person, so they see the same thing, they hear the same information they're exposed to, but one person's in charge of making it happen, the other person's just watching it, we don't see anywhere near as much activity in those key brain regions. So what that tells us is that a big part of the power of play for changing behavior comes from, in some sense, the capacity of play to create emotional and motivational changes that aren't there in the communications strategies that we've been using in the past with patients. And that is a big opportunity, harnessing these, in some sense, harnessing emotion and motivation to turbocharge learning and memory in a way that's going to add up to stronger behavior. It's a tremendous opportunity. When you think about it, play, in many respects, is not just the antithesis of, but actually might even be the antidote to some of our most vexing behavioral challenges in healthcare. Play gets us up out of our seats and makes us run around. Play can focus our attention and bring us together with other people. Play can even buoy our spirits when we're down. So, in that regard, harnessing the power of fun in the service of health by changing people's behavior might just be the most underexploited opportunity that we have in all of modern healthcare.